Hi, and this would be our last video for projectile motion. And ang i-discuss natin sa video na to ay yung dalawang natitirang cases for projectile, which is yung number 1, wherein the point of impact is above the point of release. And then yung second one is the point of impact is below the point of release. So sa pagsosolve ng mga projectile problems with this kind of cases, okay, we are using the general equation of projectile. At isulat ko dito, ano nga ba yung general equation ng projectile? Ito ay derived equation na. So hindi na natin kailangang hagilapin pa kung saan nagmula yung mga yung equation na to, pero nanggaling lang din tong lahat ng to sa kinematic equations from the previous topics. Ginamitan lang ng konting trigonometric identities at ito na yung kakalabasan. So, ano nga ba yung general equation? Okay? General equation ng projectile. Ito yon, plus or minus y is equal to x tangent theta, okay, minus gx squared divided by 2 times the initial velocity squared cosine squared theta. So, kung hindi kayo masyadong marunong sa paggamit ng calculator nyo for solving this, makakatulong din tong video na to. Ngayon, nakakita kayo ng ambiguous signs ulit. Kailan natin gagamitin yung positive at kailan natin gagamitin yung negative? Ito yung magiging rule. Okay? Makinig. So, use positive if the point of impact is above the point of release. At ito yon. So, use positive sa scenario na to. Use negative sa scenario na to. Okay? At same equation lang yung gagamitin natin. Napakadali lang kasi magsa-substitute ka lang ng formula. Siguro sa mga bago lang sa paggamit ng calculator in solving these kinds of equations or substitution of units, mahihirapan ng bahagya. Pero napakadali lang yan. Okay, so let's try solving an example using the first case. Okay? Yung first case muna tayo, which is yung point of impact is higher than the point of release. Or above the point of release. Okay, burahin lang natin. Okay, our first example is displayed on your screen. Ang nakalagay dito, a daredevil is shot out of a cannon at an angle of 45 degrees with an initial velocity of 25 meters per second. Sabi, a net is positioned at a horizontal distance of 50 meters from the cannon. And what height above the cannon should be the net be placed in order to catch the daredevil? And also, how long will it take the daredevil to reach the net? Okay, so kung i-draw natin yung scenario, kunyari ito yung cannon, and then ito yung daredevil, para siyang character. And then, saan ilalagay daw yung net? So, yung net should be above the ground. Okay? Ito yung net. Okay? Para siyang trampoline. Okay, so, magta-travel yung daredevil pa ganon hanggang makarating dito. And then, of course, this has an elevation. Okay? Wait lang. I-ano natin yung drawing natin. Ayusin natin. Kunyari, ito yon. Tapos, meron siyang elevation. This is y. Okay? Pinapasolve si y. At, ito yung point of release, kunyari. And then, pinapahanap din yung total time of flight. And of course, hindi mo to pwedeng gamitan nung dati nating computation ng total time of flight, which is kukuhanin lang natin yung first half and then i-multiply sa 2. Hindi pwedeng ganon. This time, iba to kasi yung total time sa first half, di ba, is different dun sa total time on the second half. Okay? So, medyo challenging yung problem, pero let's do this. So, ano nga ba yung mga given? We have initial velocity of VO is equal to 25 meters per second. And we have yung theta is equal to 45 degrees. Diba? And we also have yung horizontal distance from the cannon, ito, 50 meters. Okay? Sinusulat ko lang yung mga known na quantities kasi yun din yung gagamitin natin sa pag-compute nung vertical height. Okay? So, kung aalalahanin natin, ito yung first scenario, di ba? Yung point of impact is above the point of release. And therefore, we will be using plus y, yung positive y, di ba? So, y is equal to, ano nga ba yung formula natin? That's x tangent theta minus g x squared to, yung ibaba, baba is 2 times the initial velocity squared cosine squared of theta. So, kung isa-substitute natin yung values, we have 50 tangent 45, okay, minus 9.81 or 9.8 meters per second squared, x squared, that's 50 squared. Yung denominator would be VO squared is 25 meters per second, tapos naka-square, and then cosine squared theta. Ano nga ba yung cosine squared theta? Cosine squared theta is just doing the square kung gagamitin nyo sa calculator. Cosine theta, tapos i-square nyo na lang. So, this would be 45 degrees. Okay? So, let's try using our calculator to solve the problem. Nakasulat na din man yung mga given. So, we have 50 tangent of 45 degrees minus, gawa natin ang fraction, we have 9.8 meters per second multiplied by 50 squared, diba? And then yung denominator, it's 2 times 25 meters per second squared, diba? Yung i-square natin yung initial velocity. And then dito sa cosine, diba, sinabi ko kanina, you just need to do cosine of 45 and then square the entire trigo identity or trigo value. So, let's click equals and the answer is 10.8. Napakadali lang. Y is equal to 10.8 and this is in meters. Okay? So, yung mga cancellation of units dyan, mangyayari lang din yan kapag sinundan natin yung formula. So, your y is equal to 10.8. Ngayon, meron na tayong vertical height. Ano naman yung isa pang pinapasolve? So, yung pinapasolve na isa is yung time of flight. So, time of flight is equal to, ano nga ba yung gagamitin nating equation dito? Since ang pinapasolve is yung total time it takes from the release point going to the net, medyo mahihirapan tayo kung i-consider natin yung vertical component nito. So, ang gagamitin natin dito is yung horizontal component. Ang lagi nating tatandaan, kung ano man na makuha nating time using the horizontal component or using the horizontal motion, yun din yung makukuha nating time sa vertical component or using the vertical motion. Mas complicated nga lang using yung vertical motion. Kasi sa horizontal, di ba, naaalala natin, wala tayong kino-consider na acceleration kasi nga zero yung acceleration if you move horizontally. So, ang magiging equation natin dito is equal to, ano nga ba yun? X, di ba? Yung 50, yung total na na-cover na distance, divided by ano yung initial velocity mo. Di ba? Napakasimple lang. So, initial velocity would be in the horizontal direction, that would be cosine of theta. So, meron tayong 50 meters, meron tayong 25 cosine of 45 degrees. And we can now compute for the time. Diba? Napakadali lang. Let's solve for the time. T is equal to 50 meters divided by 25 cosine of 45 degrees. And the answer is 2.83 seconds. Okay? At nasolve na natin yung dalawang required for this specific problem. Again, this is a projectile motion wherein the point of impact is above the point of release. Okay, so let's proceed and solve another problem. And this time, we will be solving yung last case for projectile motion. And this would be the projectile wherein the point of release or the point of impact is below the point of release. So, sabi sa problem, you are frustrated with the book you are reading, and then you open the second story classroom window and violently thrown your book with a velocity of 18 meters per second at an angle of 35 degrees above the horizontal. The question is, if the launch point is 6 meters above the ground, how far from the building will the book hit the ground? And also, how long is the time of flight of the book? Okay, so halos same ng required quantities yung pinapasolve. Number 1 is how far, ito yung unang tanong, how far from the building will the book hit the ground? Kung kanina yun yung given, ngayon yun yung pinapahanap, yung x ngayon yung pinapahanap, and then pinapahanap din yung total time of flight. Okay, let's draw the scenario. Medyo sabi dito, ito yung 2-story building, okay? At nandito yung bintana. And then, syempre, nakabukas na yung bintana. Dito mo binato yung libro. Okay? So, paano natin i-drawing yung libro? Ganyan na lang. Okay. And then, binato yung libro. Syempre, merong angle pala. And then, babagsak siya syempre sa ground. At pinapahanap sa atin ngayon is, ito, si X. Ang tagal na ito hinahanap si X, hindi pa rin mahanap. Okay, si X, pinapahanap, you have your initial velocity of 18 meters per second. Meron ka ding height na point of launch. This is 6 meters. Ito. This is 6 meters. Okay. And what else? You have your theta with respect to the horizontal. Theta is equal to 35 degrees. Alright, so that is the given and also the illustration of the problem. Now, what we can do here is, again, let's use the general equation for projectile. Ano nga ba yun? Plus or minus y is equal to x tangent theta minus gx squared divided by 2 times the initial velocity squared cosine squared theta. Okay. Pagka ganitong problem, ano nga ulit ang gagamitin natin? Kapag ka below, di gamitin natin yung negative. Alisin na natin yung positive. Alright, so minus y. Meron ba tayong y dito? Yes, y is 6 meters. So that's negative 6 meters is equal to, ang pinapahanap dito sa atin is x. Okay? x, and then you have tangent of theta is 35 degrees, diba? Minus g, 9.8 meters per second squared multiplied by x squared, and you have 2 multiplied by your initial velocity, which is 18 meters per second, pero naka-square siya, and then cosine squared of 35 degrees. Okay? Using your calculator, napakadali lang nito, pero kung gusto mong i-manual, kailangan mong gumamit dito ng quadratic equation, yung basics ng quadratic equation. So, gamitan na lang natin ng calculator para ma-solve natin yung x. And for those who are still new of using calculator in computing quadratic equations, please keep your eyes open. Okay? So, that's negative 6, okay, is equal to x. So, you have alpha x, and then you have tangent of 35 minus you have 9.8 multiplied by your x squared divided by 2 multiplied by 18 squared, and then yung cosine, wag kalimutan na naka-parenthesis, 35, and then sa kanyo i-square. Okay? So, let's press shift, solve, and then let's try guessing. Sabihin natin 20, and press equals, and wait for your calculator to provide you the answer. Napakadali na lang nito, pero kung gusto mo ng medyo manual, kailangan mong tanggalin yung denominator nito, tapos kunin mo na lang yung magiging numerical coefficient ng x squared, yung numerical coefficient ng x, tapos yung constant. Pero since meron nga naman tayong calculator, edi why not gamitin natin? So your x would be 38.06 meters. Okay? Nasolve na natin yung x. So pinapasolve pa na isa pa is yung total time of flight. And previously, ginamit natin yung horizontal component ng velocity kasi nga mas madali yung approach na yon. So, meron na tayong x, edi masasolve na din natin yung total time of flight. This would be VO cosine of theta, and we have 38.06 meters, and the total or the denominator would be 18 meters per second cosine of 35 degrees. Okay? And the answer for the total time of flight is equal to, let's calculate, that would be 38.06 divided by 18 cosine of 35. And the answer is 2.58 seconds. Okay? So, madali lang ang projectile basta alam natin yung mga formula na kailangan gamitin. Most especially yung general approach or general equation for projectile motion. Kapag may mga scenarios na yung point of release is parang elevated or yung point of impact, yun naman yung elevated. At gagamitin lang din natin yung general equations for projectile. That's all for now. Thank you so much for listening, and I hope you enjoyed and learned so much about projectile motion. Thank you.